A new tactical missile enters service, fast, precise, and built for modern battlefields. What makes the Pralay missile so important? To understand exactly how this weapon rewrites the rules of border defense, we need to look at the technology inside it. If you enjoy deep dives into modern military strategy, hit the subscribe button to join the channel. India's borders present some of the most unforgiving geography on the planet. High-altitude mountain passes in the Himalayas are increasingly heavily fortified, protected by deeply layered advanced air defense networks. Looking at this chart plotting strike distance against escalation risk, we see a massive vulnerability in how those borders were historically defended. On the far left, conventional artillery maxes out around 100 kilometers. On the far right, strategic missiles can reach over 3,000 kilometers, but using them risks triggering a catastrophic nuclear war. Right in the middle is a massive empty operational zone. To secure these borders, military planners needed something very specific to fill that gap. A weapon capable of striking hundreds of kilometers into enemy territory with pinpoint precision, hitting targets within minutes, and doing it all entirely without crossing the nuclear threshold. The solution to that exact problem is the Pralay short-range ballistic missile. Mounted on a heavy 12x12 high-mobility vehicle, it's a road-mobile system that brings dedicated conventional firepower directly to the front lines. This side-by-side comparison shows exactly how Pralay operates. On the left, a traditional ballistic missile follows a predictable, high-arcing parabolic path shaped by gravity. On the right, Pralay takes a completely different approach. It is a quasi-ballistic missile, meaning it flies on a depressed, much lower altitude trajectory. As the animation shows, staying low keeps Pralay under the radar horizon for longer. When it does approach a target, it reaches terminal speeds of Mach 6.1 and executes active, erratic maneuvers midair, rendering standard interceptor calculations useless. Launching this weapon requires almost no preparation. Because Pralay uses a highly energetic solid propellant and is stored inside a sealed, pressurized canister, troops can drive into position and fire the missile in under 10 minutes. Once in the air, a sophisticated guidance system steering the missile ensures it hits within 10 meters of its intended mark. Commanders can swap out different conventional warheads depending on the mission, using specialized payloads to crater runways, blast through reinforced concrete bunkers, or neutralize radar sites. Combining a low, unpredictable flight path with Mach 6 speeds makes interception significantly harder for existing defenses. It ensures India can hold high-value targets at risk, even within heavily contested airspace. Developing weapons capable of outsmarting modern air defenses is incredibly difficult, and historically, it requires billions of dollars in research and highly expensive bespoke production lines. But as this component flowchart shows, Pralay circumvents those massive costs. The design pulls directly from existing, proven technology. It lifts the composite rocket motor straight from India's K-series submarine-launched missiles and borrows guidance mechanics from the Prithvi exo-atmospheric interceptor program. By repurposing these existing systems, engineers stripped years off the research and development phase. They avoided having to invent new engines or navigation software from scratch, driving the final unit cost down to roughly $5 million. Dropping the price tag that significantly alters the military math. It means defense forces can actually afford to mass-produce these weapons, stockpiling enough inventory to sustain a continuous barrage during a prolonged conventional conflict. A large stockpile is only effective if you can replenish it. Relying on foreign nations for critical weapons creates a severe vulnerability, as international supply lines can be quickly disrupted or embargoed right when a country needs them most. This map illustrates the solution, a completely localized supply chain. While the Defense Research and Development Organization led the initial design, production has been decentralized. They partnered with major domestic manufacturers and a widespread network of micro, small, and medium enterprises to supply individual components. Beyond solving a military problem, scaling up this domestic production network creates thousands of high-skilled engineering and manufacturing jobs directly within India's aerospace sector. Relying entirely on an indigenous supply chain ensures that factories can keep churning out replacement missiles no matter what happens globally. It insulates the military's logistics from external diplomatic pressure or economic sanctions. Pralay's induction provides the technical foundation for a new organizational model, the Integrated Rocket Force. This dedicated command is built specifically to unify the country's conventional missile warfare. It will manage an entire ecosystem of non-nuclear strike weapons, operating systems like the BrahMos supersonic cruise missile seen here. Within this new command structure, Pralay fills the middle tier of the range spectrum. It links short-range artillery rockets with ultra-long-range cruise missiles, creating a seamless arc of conventional firepower. By integrating high-speed evasion with a domestic supply chain, India has secured a specialized tool for conventional deterrence. Thank you everyone for your time and participation. Please politely like, share, and subscribe to Global Warwatch Network. We'd love to hear your thoughts, so please share them in the comments section below, and be sure to join us on social media.